All right, everybody, welcome to the Grand Solar Minimum channel. Today, we have a very, very special guest with us. Retired NASA and NOAA scientist, author of the book Cold Sun, Dark Winter, and his latest that was released this last December, Upheaval. John, how you doing tonight?
Doing just fine, Jake. Thanks for having me on.
John, this has been a long time coming. We were reached out to you weeks ago. We are very excited to have you on our channel. I mentioned in our communication that we consider your work as a foundation and beyond for our channel. Thrilled to have you here, and it's an honor. Thanks again for being here.
Glad to be here.
All
And
right.
thank you for all the work you and Laurie have been doing. It's great to see your focus on the next grand solar minimum. I wish there were more people like you and Mari helping get the message out.
It's growing. I can tell you that the results right now are tremendous. There are more people engaging in our community about this than there was, say, 4 weeks ago. So,
Good.
yes, that's our main goal here at this channel. We want to work with everybody that's on this topic. Okay, so I'd like to ask a few questions here, John. And I know you've probably been asked these quite a bit. The first one I wanted to ask you was, when will it be obvious that a new cold epoch has arrived as predicted in your book, Dark Winter?
Well, actually, it's already obvious to a lot of people on the planet. Regrettably, the media still does not tell what's happening to the extent that they're still pushing the man-made global warming story. But if you were in Great Britain in February, you would already know that the next cold epoch has begun because all of a sudden you've been told that cold weather has killed much of the vegetable crop and you can't get lettuce or cucumbers in your grocery store. And in fact, there are actually people fighting over vegetables in Great Britain grocery stores in February because of the cold weather Europe was getting. So over there, a lot of people may feel that it's already started to hit. Um, on the other side of the planet, the capital of Australia, Canberra, where my director of research for our earthquake research company is, said they just set new cold weather records down in Australia. So it depends on where you live, but certainly here in the U.S., we're still dominated by the media and the government, or at least the previous government, telling us something about the climate that's probably not accurate. More specifically, to know that the next cold epoch has hit with certainty will come, in fact, when we have that first bitter cold winter that lasts until spring and destroys our food supply to a large percentage. We did have losses this spring, but the media hasn't discussed much of that. So the short answer is when things start to disappear in the grocery store and the supermarket because of cold weather damage, then probably people will stand up and say, what's going on? I thought everything was supposed to be getting warmer, not colder.
Yeah, and you mentioned the media not communicating. We've done several updates that we have little, 2, 3 minute clips that we show, and a lot of the stuff that we report on is not in the mainstream media. You really have to dig to find some of these, freak hailstorms. You talk about South Australia setting cold records. I got an email from a gentleman who lives in New Zealand right now, and I guess they hit minus 11 degrees Fahrenheit, and that's pretty cold for them at this point in their winter. They think their winter's 5 to 6 weeks earlier than what it's supposed to. So there is evidence of what you just said there all over.
Your comment about New Zealand, one of the big myths that we keep hearing about is the fact that glaciers all over the planet are shrinking and will disappear. New Zealand's, I think, got 26 major glaciers, and they're all growing at the fastest rate they've recorded in the modern satellite era. So again, who knows about that here in the U.S.? No one, because the mainstream media won't discuss it.
Right, exactly. All right. Another question I had for you as well. What is the current status of the Earth's temperature, and can we trust what the government is telling us?
The current status is that we've just come off a peak of warming in the 2015-2016 period. But as I predicted in early 2016, this would be the last such warm spike in global temperatures that we will have probably for the next 400 years. Since early 2016, global temperatures have continued to drop. We had another very steep drop in June, from May to June. I believe in May we had an anomaly of 0.43, and it went to 0.26, so a big drop from May to June. And I expect this drop in temperatures to continue and to be essentially unabated until we get to the 2040s. So we'll certainly see ups and downs. Weather and climate do overlap on a yearly basis and every 2 years. So you will see variations, ups and downs that are quite rapid and large. But we're on the downside of the 206-year solar cycle. There's nothing mankind can do about it. We'll just have to recognize that global temperatures are going to continue to drop. So that's the current status. Right now, we are, if you look at a straight line graph, there's been effectively little to no change in global temperature for 20 years now. Prediction was made in April. I posted that online. The prediction said two things. It said global temperatures would drop over the next year, which they have done exactly as I predicted. But I also said that the spike in temperatures, which was produced by a spike in solar heating, nothing else but solar heating, was probably going to be the warmest that the human species, our peoples, will see for probably 400 years. The reason for the 400 years is the 206-year cycle. We're now going up and we're peaking and we're heading down rapidly. And when we come out of this and then head back up and start warming up, it'll be in the 2040s. But even after that, we won't get very warm. So it'll be at least two cycles of 206 years, so 412 years before we see any significant warming again. And quite frankly, that far out, you see other major solar cycles at play, and the analysis isn't done on those. Some people are looking at those cycles, but it could be that even after 400 years, it'll only get much colder.
Some are predicting a Maunder class minimum. What are your thoughts? Also, what is the time frame to reach that point? And could you expand on the last Maunder minimum and how that affected civilization?
Right. The first part of your question is how soon and will we get down to a Maunder class solar minimum? There are many who believe we are heading into a new little ice age, which in terms of the Maunder minimum refers to the period of time when the sun had dropped in intensity and was the coldest period of the so-called little ice age. That was 1615 to 1745 specifically. That's the Maunder minimum. And that was a period of time when New York Harbor froze over and stayed froze over. The Thames River stayed froze over. The Baltic Sea stayed frozen over. Countries, people could go from country to country across the frozen Baltic Sea. And it was so cold and the ice was so thick that they actually built hotels and shops and other facilities out on the ice for travelers that were going back and forth between countries over the frozen Baltic Sea. That's how bitterly cold it was. And of course, during this period of time, we had some of the world's greatest warfare or battles going on. Starvation was common. Famine and plague were common. Illness was everywhere. Life expectancy dropped dramatically. There are a number of very good books written on this period of time. And I recommend anyone that wants to do so just research the Maunder minimum and that period of history, especially European history, and you'll see how difficult life was, how crops routinely failed, people starved to death. It was not a good time to be alive. And unfortunately, our Russian colleagues are totally convinced that we are heading into a little ice age again, like we were in the Maunder minimum from 1615 to 1745. My own research says we are not heading that deep, but it'll be bad enough. We believe we'll be seeing not a Maunder minimum, but a Dalton minimum, which lasted from 1793 to 1830. That was pretty bad. That was pretty cold. Rampant warfare existed throughout Europe during that period of time. The War of 1812 struck here in the U.S. So there was lots of warfare, lots of famine, lots of death and destruction from the collateral effects of war. But also, you had this bitter cold that had descended on the planet. Not as cold as the Maunder minimum, certainly bad enough to destroy crops. And lest we forget, in 1816, here in the United States, the so-called year without a summer, we literally had no summer in the New England states.
Wow.
We had snow and freezing rain in the dead of summer in August in 1816.
You know, and I've reached out to local meteorologists back home from where I'm from in Southwest Ohio. And, you know, we go back to talking about how the media doesn't really talk about what's happening. And I wanted to pick his brain about what he thought was the, you know, what was going to happen with this next upcoming minimum. And this is the same answer that I've gotten from most mainstream media, is that there's, you know, the CO2 is going to, you know, overturn this whole thing. And that leads me to my next question. What is the truth about CO2 and its impact on the climate change?
Well, of course, that's been the grand theory. It is a grand myth, in my opinion, and that of many other researchers, that CO2 is the primary driver of climate change on Earth. There's simply no serious science that supports that contention. What we do have coming out of the United Nations, however, are lots of bogus myths and bogus science. The ClimateGate scandal showed very clearly that the scientists at the United Nations Intergovernmental Panel on Climate Change were falsifying the data, were hiding the data that showed the planet was actually cooling in a number of years. And we also have coming out of that group, echoed during the Obama years, many models of climate that were developed costing billions of dollars. And what we now know is those models were in error by 200, 300 or more %.
Goodness.
These models are absolutely worthless from a scientific standpoint. Unfortunately, again, the mainstream media uses the output of these very poorly constructed models and the extreme predictions for sea level rise and global temperature rise by the year 2100 as the basis for political action and social action here in our country. It's very sad that bad science has taken over in the media and during the Obama years in our own government.
Yeah, I don't understand what the sense of not exploring this and making it a topic of awareness throughout. Since I've been researching the grand solar minimum with solar sunspots, how CO2 does not drive our climate. So it's
well, I didn't answer your question, and I apologize. But aside from the models and the UN climate reports that are all based on mankind's CO2, probably is aware of this, that CO2 is actually a trace gas that is such a very small component of the atmosphere that it has very little to do with climate. Does mankind contribute to CO2? Yes. Does it have any kind of warming effect? Yes. But in the grand scheme of things, it is a very, very small component of global temperature. Clearly, the sun is overwhelmingly the central source and the most powerful force in the solar system for driving the temperature here on Earth. CO2 produced by mankind is at best only 5% of naturally produced CO2.
Right.
So again, all the numbers show that CO2 cannot be the primary driver, that the falsified, manipulated reports out of the UN have been showing for more than 3 decades now. Very sadly, it's all bad science.
Yes, agreed. Recently, we saw a ice shelf break off at Larsen C, and it leads me into this next question.
Yes.
What is the status of sea level rise, and how bad is the threat?
Sea level rise is continuing, although the rate is slowing down. That's a very key statement. The man-made global warming community says as long as CO2 goes up, then sea levels will go up lockstep. There's some relationship, but again, a very small relationship. Sea levels rise and fall for a number of reasons. The primary reason is the heating of the oceans, which causes them to expand. Our globe, as you can see behind me, primarily 71% water. And as that water heats up, it expands. So as long as the sun has been heating up for the past 200 years now, we have seen a gradually expanding, rising sea level. However, Dr. Niels Axel Morner and a number of other experts on sea level and myself know very well that there's a cyclical pattern to sea level rise. And it occurs pretty much on the same cycles as the sun. As the sun warms the planet, sea level rises go up. And as the sun starts to cool and that cycle drops, then of course we'll start seeing sea levels drop as well. We had a very important news conference, August the 21st, I believe, 2014 in Miami. I don't know if you heard about it. We indicated very clearly that sea level rise is a function of the sun and the heating of the oceans, and that beginning no later than 2020, we would see the rising sea levels start to abate. By some measurements, that's already begun. We indicated in that press conference that between 2014 and 2020, we would see the changes in sea levels start to manifest themselves. There's also a big question about sea level rise, even though, again, these fabricated, these falsified data sets that are being used by very poorly constructed climate models at the UN say that we're just going to see more and more sea level rise between now and 2100. History and actual measurements show that's not the case at all. Whereas Al Gore is telling the world that Florida will be flooded with 21 feet more of sea level rise between now and 2100. The reality is, if you use the gold standard for measuring sea level, that there's going to be very little sea level rise between now and 2100, even with the current rate of growth of CO2. There's a big disparity right now between the satellite measurements and the actual tidal gauges, which are the gold standard for measuring sea level. And these tidal gauges are all over the planet. The satellite measurements show a rapid growth in sea level rise, but the gold standard says, no, we're not seeing it at all. Instead of 3.2 millimeters per year, which the UN says we're seeing, the reality is it's closer to 1.2 or even less per year. That says that there's no big concern whatsoever for future sea level rise, even with the current rate of warming. However, now that the sun has maxed out and is on its way down, the oceans will start to cool, and I believe in the 2030s and 2040s, we'll be right back to where we were during the Dalton minimum, where sea levels dropping dramatically 20 to 25 centimeters over the next 15 to 20 years, getting us back to where we were in the year 1800 at the bottom of the Dalton minimum. So that's what we said in our news conference. But again, the CO2, the global warming crowd, Al Gore and company, all they're doing is talking about bad science, bad models, and scary predictions that aren't going to happen.
Yeah, you mentioned bad science, and the next question I had for you as well. I heard rumors last year that we would be an all-water event, that the caps, everything would be melted by 2017. Are the Arctic, Greenland, and Antarctic actually melting?
The Antarctic and the Arctic, just like all other natural phenomena, go through cycles. Right now, and for the last 2 years, the Arctic has been dropping in temperature, Arctic sea heights has been growing, and that's been the case with the Antarctic. Bear in mind that the Arctic and the Antarctic did see a large spike in melting during the same time we had that spike in solar heating. That's exactly what we should have seen. And for those who looked at the documentary that was done on my book, Dark Winter, I actually showed in that video, which was produced in late 2014 and early 2015, that the sun was going to produce a spike in activity. And it happened exactly when I said it would. So again, natural cycles are at play. We did see a lot of melting in the Arctic and the Antarctic. That's now turning back around. And if you look at the long-term picture in the Antarctic, there's been very little warming whatsoever for over 100 years now.
Yeah.
And in general, the Antarctic continues on a very slight cooling trend and has for decades. The Arctic is a little different. It's more subject to northern hemisphere weather patterns and the polar vortex, which is nothing more than a counterclockwise rotation of winds. The Arctic is not at all a monolithic entity like the media would like you to believe. For example, some areas of the Arctic have 1 meter of ice thickness, but other areas have 5 meters or 15 meters of ice thickness. So it's a very different non-uniform area to study. So again, going back to the science, it's very different than what the media is telling you.
Yeah.
Right now, both Antarctic and the Arctic are in a cooling trend, which is about 2 years long right now.
My favorite headline so far this year about the Arctic was the group of researchers who are going to study the effects of global warming, and they get their ship stuck in ice and had to abandon the entire research project. So that right there should have been the first red flag that folks like yourself, this is a serious topic that should be raised, awareness should be raised as well. And I saw something a couple days ago that really blew my mind. Megyn Kelly had asked Vladimir Putin about Trump's recent decision of pulling out of the Paris Treaty, and the look on his face was his eyebrows raised, and he looked at her as if to say, "Are you serious? Record snow in Russia, and it's cold and rainy right now." And that's all he had to say. His feeling about it was like, "Are you serious?" Basically, Trump did the right thing. And I guess where I'm going with this is, why are so many other global leaders not following President Trump's lead on getting out of the Paris Climate Accord that happened in December of 2015?
Several good reasons for why they aren't. First off, it's important to understand that even the Kyoto Protocol of the 90s was bought off by many European leaders, and they began to implement CO2 controls on their industry, and they got into carbon credit trading very early. Europe, generally a socialist union with the European Union, adopted very quickly any UN report that came out and recommendations from those UN reports. And so they are way ahead of the US, China, India, and other countries in implementing the UN Accords. Many of the people that worked on those science committees, the leading science institutions were in Great Britain, a member of the European Union. Much of this got started in Great Britain during the Margaret Thatcher years, and many of the people that end up in the United Nations Environmental Development Organization, came out of the UK, and then Germany and France and so forth did their part. So they were well ahead of us and still are implementing Kyoto protocols and picking up what they said they would do in the December 2016 Paris Accord. I'm sorry, 2015 Paris Accord. So they are vested now. That's the big issue. The U.S. was never fully vested. California, of course, is fully vested in the Paris Accords, but the U.S. government is not. Thank goodness for the conservatives in our government who fought this. But the Europeans, their businesses, their banking, their environmental organizations, they're all on the same sheet of music. So it's going to be very difficult for them to change. It's going to take a long time for them to change and go back to the reality of good empirical science instead of political science as their motivations. Let me go to a specific issue, which is the one of carbon tax. The carbon credit and carbon tax structure is already going forward in Europe, and to many government entities in the European Union, their debt structure, their lackluster growth in economy makes it very difficult for them to impose taxes. With this CO2 myth, they've been able to convince many of their people to approve these carbon credit and carbon taxation structures. So now they are wedded to that income stream in their governments. That makes it even more difficult for them to change. Fortunately, we never implemented a carbon credit here. Fortunately, back in 2008 and 2009, the Chicago carbon credit exchange collapsed after word got out that the Earth was cooling, not warming. So that all shifted to Europe, and that's where it still resides. Fortunately, the U.S. never bought in to the Kyoto protocols and especially the 2015 Paris Climate Agreement.
Just curious, do you know how much that would have cost American taxpayers if we had gone through and stayed in this accord?
Yes, there have been a number of estimates. The ultimate estimate is something like $1.4 trillion over a 10-year period would be the cost to the American consumer and taxpayer to implement the Paris Climate Accords. Obviously, our economy is still anemic at best. We are not seeing the kind of growth we should. We're now a country that's heavily burdened with debt. And so for us to pick up another $1.4 trillion in debt by imposing climate restrictions, that would certainly be onerous, if not deadly, to our economy. Bear in mind something very important here. Regardless what the Europeans do in implementing the Paris Accords, if every country implemented the Paris Accords as they agreed to do, it would have very little impact on the climate whatsoever.
It's a shame that it took an administration change for this to happen, for our government to pull us out of this treaty. I think our current government saved this country a bunch of money by doing it's the right thing, and more evidence has been coming out since 2016 of, like you mentioned earlier, they're fudging numbers. The data is just simply being cherry picked. And I've had, since we started this channel, we get people that ask us questions, and they cherry pick from the data. They don't want to reveal the entire picture of everything, and that's why we do a show called The Big Picture, because we want everyone to see the entire, all the ingredients, not just one factor. So,
and that's what I like about what you're trying to do. The title that you have, the Grand Solar Minimum, your website says it all. The Grand Solar Minimum is based on cycles that are 100, 200, or more years long. And for the mainstream media, they pretty much have to ignore these grand solar cycles and grand solar minimums and focus on very narrow periods of time when the Earth is warming, and from that extrapolate up and say, well, this is the way it's going to be for the next 100 years, when in fact we know that it's up and down in
Yes.
a general trend and never a straight line cold or a straight line warm.
No.
So yes, the mainstream media and the global warming movement have intentionally cherry-picked the data that they like and ignored the vast amount of data that says climate is driven primarily by the sun.
When we talk about how the TSI does change during the maximum and the minimum, and they talk about the average is 0.1% variance during this minimum, how far down in TSI do you think we'll go? Where do you think we'll bottom out? What are your predictions for sunspots through cycle 25, 26, 27?
I'm really pleased that you asked about TSI because it's total solar irradiance, something all of your listeners need to be aware of. Total solar irradiance is the amount of radiant energy that's delivered on the upper atmosphere of the Earth. And as that varies, so varies the climate on the planet. If we are getting too much solar irradiance, we get hot temperatures, we get high sea levels. If we don't get the right amount of TSI, then the Earth gets colder and sea levels drop. And basically, that's one of the key measurements of which direction our climate is going, is following that TSI, the total solar irradiance. A couple big things to understand about it. Number one, you're right. Between the 11-year solar cycles that we learned about in high school, every 11 years the sun grows in intensity and energy output, and then it drops off, and then it picks back up again. And at the peak of these 11-year cycles, the sun's magnetic field reverses. So these are things we learned in high school. At the bottom of these troughs, where the sun's activity is lowest, we do see a big drop in the TSI. But this really doesn't affect climate unless you have multiple 11-year cycles showing much lower than normal energy radiation from the sun. Then we have a climate change. And that's what we're looking at in the next cold climate epoch, the Eddy minimum, it's called, named after Dr. Jack Eddy, who passed away a couple of years ago, unfortunately. Great scientist, but the next cold or grand solar minimum, named for him, we believe will last for at least 22, maybe 33 years. That's 2 or 3 of these 11-year solar cycles. And during that period of time, the Earth will get very cold. Well, that's number 2. Number 1 was the fact that even though we have the dips, they don't amount to much climate variation. But when you combine them, number 2, then you get that. That's also reflected in the sunspot count. When you see sunspot counts that average only 50 sunspots on average at the peak of these 11-year cycles, and you get 2 of those that are 50 sunspots or less, then you're down into the Dalton class of minimum, and that's where we think we'll be through the next 20 to 30 years. The other thing to bear in mind, a third point actually about TSI, is how we measure it. Even though it's measured by satellites typically at the upper atmosphere of the planet, there's a lot of variation there. And the variation comes from the fact that we've used different satellites, 8 or 9 different satellites in the last, since 1979, to measure this solar irradiance, this TSI. Right now, the source satellite is the number 1 satellite that we're using, and it's running about 1,361 watts per meter squared. That's about, well, again, this 1 meter squared on the surface of the upper atmosphere, and we see about 1,361 watts. In the previous satellites, though, we saw 1,366 watts. Now that's important to note. We can now combine the 2 groups of satellites, the ones that were at 1,366 and the new source satellite at 1361, and we come up with a composite. Bottom line is, what we now know from the TSI studies over the last 30 years is the very slightest change in that TSI reading can mean the difference between the modern warm period that we're in and a little ice age like we had in the Dalton minimum, the Maunder minimum, 1615 to 1745. In fact, you're probably familiar with the phrase that the Earth is revolving around the sun in what's called the Goldilocks zone, not too hot, not too cold. Actually, we live on a knife's edge in that Goldilocks zone around the sun. What I mean by that is the very smallest change can bring on an ice age. Instead of an average of 1361, if we were at 1360 and stayed that way for 20 years, we would be in the Maunder minimum. That's an unbelievable statement, but that's what history has shown us, that 1 in 1,361 parts is all that we need to see in a change in the sun's intensity to give us a new little ice age.
Well,
we think it'll be less than that coming up. Hopefully, it won't be as bad as the little ice age and the Maunder minimum, but it's still going to be very cold, dangerously cold for our agriculture industry worldwide. But I'm so glad you brought up this matter of TSI. Thank you.
I wanted to add real quick to the TSI. I'm glad you mentioned the two different readings. And I've been following the source website myself, and I've noticed just looking back, it goes all the way back, I do believe, to 04, maybe 07. I'm not sure when they started. But since October, we have been sitting at somewhere between 1360.9 and lower than that. Nothing below 1360. But I noticed the two difference that if you go to the NASA website, they'll show 1365. Then if you go to source, they'll show a different number at 1360. So I'm glad you touched base on both readings. They do come into a factor at some point.
You can use either standard. If you use the 1366 standard of the other 8 or 9 satellites, their aggregate average, then you have to drop 3 parts of that lower down to 1363 to get down to the Maunder minimum. But if you use the standard of the source satellite at 1361, you only need to drop 1 watt per meter squared to get down to the Maunder minimum. You can use either standard as long as you know which one you're using.
Gotcha.
Of course, it's a great satellite. It's got 4 different measurement instruments. I hope we continue to use the combined data from the other satellites and the source. The problem we have with a single-use satellite like the source is the fact that there may be changes in the physics of the instruments that are measuring the TSI. And for example, we've had other satellites whose platinum resistors that were used to measure temperature had gone out of range of, there's an operating range that they exist in, and their data went out of the range, which indicated a failure of a component. That's the problem when you rely on one satellite and one instrument, because you obviously want to get continuous, averaged data and not rely on one data set and one satellite.
One of the things I'd like to talk about when we were talking about that fluctuation of TSI, when you were doing your research, as I understand, you have researched Eddie's research.
Yes.
There were places around 2009, I believe it was, where there was a variation over 2 weeks of 0.34%. There was a drop where there was a sunspot going across the base of the sun. Are you familiar with that incident?
Yes. Mm-hmm. And okay. There are others. For example, when Mercury and Venus transit across the disk of the sun, they also produce a very significant drop in TSI here on Earth.
Thank you, John. So as we get increased coronal holes, if you want to talk about the history of coronal holes and how they are growing, I would like your opinion on how those coronal holes, because as we know, that's a cooler area on the sun. If we keep getting these large coronal holes and increased particles, they're coming in and they're increasing cloud nucleation. That nucleation is creating additional refraction back into space. That refraction in space is dropping the TSI that we're getting here on the planet, which leads me to believe that the increased amount of galactic cosmic rays, you're following that data too, right? Okay, so we're, say 16% in the middle, the north part of the country, and 19% in the northeast in galactic cosmic rays over the last 10 years. So if that continues to escalate like that, then you take the data from Dr. Kirkby from CERN. Are you following the cloud project there?
Yes.
Okay, so if you take Kirkby's original work and you put that together and you add all the aerosols created by the aircraft and the aerosols created by the ships and created by humans, then you have even more of this soup that is going to increase the amount of refracted TSI and drop even lower. And we have seen numbers talk about the amount of energy created by CO2 as being 1.5, 1.6 watts of warming, but when you look at the math of what galactic cosmic rays will do with the amount of aerosols and other junk we got up there, you're talking as much as 6 to 8 watts of decrease in TSI. So if you add that all up and you speak to the coronal hole streams and how they can possibly drop the TSI, what are your thoughts to that, John? Could you speak to that? I know that's sort of a long-winded question. Tell me what you think.
Your question is actually all-encompassing of a lot of things that are going on with our sun. And let me step back and try to back into an answer for you. When the sun goes through its cycles, and right now it's at the peak and on the downslope of the 206-year cycle, that cycle basically produces a number of measurements, a number of parameters that I follow and others like me follow. Coronal activity, solar wind, cosmic rays, atmospheric nucleation from cosmic rays, cloud cover, aerosol counts. All of these things end up becoming part of the soup of measurements that we all look at to determine, is this consistent or not consistent with these solar cycles. Bottom line is they're all very consistent. And let me add one that you did mention, the Danish scientist Dr. Hans Fenmark, who has shown through his research for quite some time, many years, that increased cosmic ray count does end up nucleating cloud cover worldwide. And the more cosmic rays, the more clouds we have, the more clouds we have, the more reflecting of the incoming sunlight we see. And what does that mean? It means we get colder. The more clouds, the colder it gets. The more reflected sunlight that doesn't reach the surface of the Earth, the warmest. Obviously, that goes back off into space, reflected from cloud cover. So what we are seeing now, for example, are the largest, highest number of cosmic rays hitting our upper atmosphere than we have ever recorded since the satellite era began in 1979. This is striking. If you look at cosmic ray counts and compare them with the last 4 or 5 or 6 11-year solar cycles, there's a direct inverse relationship. When the sun is active and reaches the peak, then the cosmic ray count is very low. When the solar activity is low, cosmic ray count is very high. And the reason for that is the solar wind that's coming from the sun and the increased magnetic field of the sun tend to push out all of these cosmic rays that are coming into our solar system from the rest of the universe, the rest of the galaxy specifically. And as long as these cosmic rays are being kept out, then we have relatively low cloud cover. But now that the sun is weakening, the solar wind is weak, the magnetic field of the sun is weak, these cosmic rays are now coming in at a greater rate, the highest rate we've ever recorded. So this says, according to Dr. Svenmark's work and the work done at CERN, that yes, we should expect to see cloud cover grow, and we should expect to see a colder planet as a result. But again, that's very consistent with the 206-year cycle. That's exactly what we should be seeing right now, leading into the Eddy minimum over the next 20 years. And they are all symptomatic of what happens when we have a change in climate.
And our hypothesis on that is if you have the exact same amount of TSI and we have the exact same amount of galactic cosmic rays that we had during the Maunder minimum, that increased amount of particulate created by jets, created by ships, created by automobiles, and all the other pollutants and aerosols going into the sky. We believe that if that exact same circumstance were to happen today as happened then, it could be worse now because of all the additional particulates that are in our atmosphere. That is just food for the nucleation of particles to interact with as they travel through our atmosphere and create that cloud nucleation.
Well, you're certainly correct that any increase in nucleation aerosols leading to cloud formation would, again, reflect sunlight and make the Earth cooler. Let me add a comment to this. One thing we haven't mentioned is the impact on volcanic activity in climate change. About aerosols, that's where you get a great deal of periodic aerosol injection is from major volcanic activity. Go ahead, Jake.
Sorry, yeah, actually that's kind of funny you mentioned that because I was getting ready to shift gears. Another part of the grand solar minimum that we really haven't touched base on, done a lot more focusing on the weather and climate and the crop situation, but there is another aspect to the grand solar minimum, and this is really covered in your latest book, Upheaval. But why do catastrophic earthquakes and volcanoes seem to come at the same time as these solar minimums?
Yeah, that's probably one of the great unanswered questions of our era. We deal with so many questions we read about in the newspapers every day about Russian collusion in the election and other absolutely worthless topics, where clearly one of the most important questions we should be asking is why do we get our worst earthquakes and our worst volcanic eruptions during these grand solar minimums, or what I call solar hibernations? Because that tells us what's going to happen in the future. What we do know from the research very clearly is that we do see the worst earthquakes and worst volcanic eruptions as the sun goes into these deep minimums, these hibernations. When the Earth gets cold, we see these catastrophic earthquakes and volcanic eruptions. The mechanism is still not understood, and there's a reason for that. In the last 8 years of the Obama administration, unless you were doing man-made global warming research, as a researcher, you didn't get any money to do that research. Everything had to be based on global warming and supporting the myth of global warming.
Wow.
Otherwise, your university, your science department did not get any government grants. And that's important because my theory for climate change, the relational cycle theory, has proven to be far superior to the greenhouse gas theory in predicting climate variation. Whereas the global warming CO2 community relies on the greenhouse gas theory to produce global warming, solar activity and the RC theory rely on global cooling. And obviously no one's going to fund global cooling research during the last 8 years of the Obama administration.
Absolutely.
Right now, we're seeing a lot of changes back to hard science, back to data, instead of politicized science, models that don't work, scare tactics by the environmental community to raise money and to push for political change for something that's not needed. Hopefully, we will see the Trump administration, as it matures, to start to turn the tide of bad science back to good science.
Speaking of that, let's talk a little bit about the history of earthquake activity in the United States over the history of these minimums. Let's talk about the earthquakes that went up through the middle part of the country, through the west coast to east coast, actually, and the history of those with the history of these minimums. Just discuss how throughout history, going back, as we see the correlation of these types of catastrophic earthquakes, I think the strongest one was a 9.0. That type of activity. Let's talk about the history of the earthquake versus solar minimum, or alongside the solar minimum, so people can realize we have a history of this type of earthquake activity in the United States alongside these grand solar minimums. Looking at how it was back then versus how it will be going into the future.
Well, fortunately, picking up from the last question, we now know that when we go into these solar minimums, we have these waves of catastrophic earthquakes and volcanic eruptions. That's what history has shown going back thousands of years. Our most recent work, which actually was years of science put together in one book, which you mentioned, Upheaval. Let me see if I've got this handy. This book, which was published in December of 2016, documents very clearly this collateral damage from solar minimums and cold climates and earthquakes and volcanic activity. In this book, we go through in detail, show why California, Oregon, Washington, Alaska, the central United States, South Carolina, Puerto Rico, all of these areas are going to see catastrophic earthquakes as the sun cuts back on its energy output and goes into a solar minimum. That's what the science says. That's what history has shown repeatedly. And so we should start getting prepared for not only a new cold era, but our worst earthquakes and our worst volcanic eruptions that we've seen in over 2 centuries. And that's all documented in Upheaval.
Yeah, speaking of Upheaval, thank you very much for the copy of that book. A great read so far for me, and I'm starting to understand a lot. This is all coming together for me. I'm having that aha moment myself right now during my research and everything. And, I also wanted to mention, I didn't mention this in the beginning of our intro, but you hold a pretty high seat for a prediction center at the Earthquake and Volcanoes. Could you expand a little bit about that for us?
I am the CEO of the International Earthquake and Volcano Prediction Center. Fundamentally, that's a global collaboration of seismologists who have, over the years, many decades in some cases, developed techniques for improving the science of earthquake prediction. These scientists, the world's best in their field, came to me in late 2011, and they asked for me to put together a company here in the United States to bring together all of the best scientists in the world in the field of earthquake prediction and seismology. So we did this. We formed the International Earthquake and Volcano Prediction Center, the IEVPC, in February of 2012. We've since gone through 3 test phases in the process of trying to develop a fully integrated chronological prediction system. And I'm very pleased to say we've had tremendous success in doing so. So thanks for asking. The IEVPC, we think, will reach a state of acceptance internationally that we're hoping for in the next few years. Sadly, during the Obama administration, we've had the U.S. Geological Service, the #1 authority, on geology and seismology here in the U.S. Pretty much put their thumb down on groups like ours or anyone else that wants to predict earthquakes. Sadly, for decades now, the establishment science in the U.S. government says that no one can predict earthquakes, even though we've shown that we clearly can, and others have.
Yes.
Sadly, the science establishment has put up barriers to groups like ours around the world who have shown that we can predict earthquakes.
Back to your book, Upheaval, what can be done to prepare for a catastrophic series of earthquakes predicted in your book, Upheaval?
Well, the good news about that is where my previous book, Dark Winter, talked a lot about the science of going into the new cold era. We didn't talk much about preparation. I had many people that came up to me and sent me emails and during presentations would ask how to prepare. So your question is appropriate. So what we did as a team of researchers, we actually put a lot of how to prepare for these catastrophic earthquakes in the book Upheaval. If you look at the book, it describes not only the threats that we actually will face and the probabilities of catastrophic earthquakes in California, the central U.S., and the New Madrid seismic zone, for example, but we actually say for individuals and families, for businesses, and for government entities, we give in each category a host of steps of preparation that one can go through. So the book, although it has a lot of great science in it, is really written for the average person on the street and is very much directed at how to prepare for these new catastrophic earthquakes that history shows are coming with this next climate change.
It is written for everyone to understand. You don't have to have a PhD or a master's to read this book.
Right.
John, you did a very excellent job in translating this information so the average person can get this information. I guess my last question I have, it's a three-parter, and it goes along the roles of, can mankind really do anything about climate change, and speak about geoengineering, and finally the roles that volcanoes might play in a climate change.
Yes, mankind can affect the climate, but right now only on a very small scale. There have been lots of studies done by me and others with regard to sending large fleets of aircraft around the planet, dumping aluminum powder and barium sulfate powder and things of that type. But you're talking about many years, a great deal of money in the hundreds of billions of dollars just to get any meaningful change. Let me give you a for instance. In the 1991 volcanic eruption of Mount Pinatubo in the Philippines, it lowered global temperatures dramatically for almost 3 years. To do the same amount of global cooling, we would have to put up hundreds of aircraft at hundreds of billions of dollars cost to lower the temperature for 2 or 3 years. We simply cannot afford to do that. Most countries on the planet are heavily in debt. No one has that kind of money to spare. So I simply don't see the kind of geoengineering that you're talking about happening anytime soon because it's cost prohibitive. Furthermore, all you have to do is wait till the next major volcanic eruption and you're going to have your global cooling produced anyway. Furthermore, all you have to do is wait for the next climate change, which is now coming, and you won't need to do this geoengineering anyway. Geoengineering got its start, of course, as another scientific myth to try to cool off a planet that's going into hyper warming caused by mankind's industrial CO2. So it's a myth built upon another myth. It simply isn't going to happen. And it's a moot point anyway, since now that we're heading into the next solar minimum, the planet's going to get very cold. There's no need for geoengineering.
Yeah, and I'm glad you mentioned that, because we come from a community where a lot of people believe the government sprays chemicals in our atmosphere on a daily basis. It was really important that you mentioned the cost, because you're right, nobody has that kind of money to do a continuous spray. People think that the atmosphere is constantly sprayed with, chemicals to change the weather, and like you had stated, it would just simply cost way too much money to do such.
There's a very good example of how mankind can affect climate. There's several very good studies done on this, but they're all regional, they're all local. One of the best studies done, however, was after the 9/11 terrorist attack. During that period of days, we had no aircraft flying anywhere in the U.S. What we found out from that was that the aerosols being released by normal aircraft exhaust engines were in fact causing a warming effect. But it reached a static level. So when the aircraft stopped flying, the particulate matter dropped because the aircraft exhausts weren't being produced. And we actually saw a cooling trend. But then when the aircraft got back up again, we saw, the level of aircraft aerosols back up, then things returned to normal. There was another study done in India which showed that industrial activity producing CO2 and other greenhouse gases did contribute to a cooling in a certain region near India. But again, it was localized. It was regional at best, certainly not global. The only way that we can show for sure that there's a global impact is when we have a major eruption of a volcano in the class of volcano explosivity index 6 or 7. Then we get global climate effects. But for mankind to produce it, again, hundreds of billions of dollars and hundreds of aircraft flying at the same time to equal only what we saw in the Mount Pinatubo eruption, giving us 2 or 3 years of cooling. We simply cannot affect the climate, and in no way affect it to the degree and the scale that the sun does on a daily basis.
Right.
Hey, John, could you explain the importance of the double peak during this solar cycle, and also the importance of the second peak being higher than the first peak?
Thank you very much. It's probably another question that we should be seeing in the mainstream media, but of course they don't want to talk about it. The reason they don't want to talk about it is because for any solar scientist who studies climate variation based on the sun, the peak of activity in this current 11-year solar cycle, number 24 it's called, solar cycle 24, is truly unique and truly indicative of how controlling the sun is. Basically, in every 11-year solar cycle, you have an up and down, the sun gets active and then inactive. At the very peak, you don't have a smooth peak. It's always a double peak, and then it drops off into the next cycle. In solar cycle 14, the second of that double peak was the more powerful. And it was based on that I predicted that 2015 and 16 would see a spike in global temperatures, because it produced a spike in solar activity. Whenever we look at long-term solar activity, I'm talking over hundreds of years, going back to when we first began looking at the sun's activity, and right after the telescope was invented or made popular in 1610, we find out that when we have a solar cycle with a very active secondary peak at the top, when you get a small peak and then a larger peak before it drops off, that happens only just prior to a major cold era beginning. And that's why this last double peak at the top of the 11-year solar cycle is so important. It's the sun sending us a final message to get prepared for a new cold era.
Thank you very much, John. All right, the next thing I wanted to add on was with your predictions. I would like to know, have you reviewed Valentina Zarkova's work? If you have reviewed that, how do you think that influences your predictions as far as sunspot counts for cycle 25, cycle 26, and cycle 27? Could you share your thoughts on what you think about Valentina Zarkova's work?
Dr. Zarkova is at the University of Northumbria in the UK. She and her team came out about a year ago with a study based on the sun's magnetic field and how the magnetic field of the northern and southern hemisphere of the sun are at various times in phase and then at various times out of phase. And what she found out is that when they're out of phase, they cancel each other out to an extent. And during these periods of canceled magnetic field, we have our solar minimums, we have our solar hibernations, and the Earth gets very cold. This is very profound and great science. Dr. Zarkova and her team were roundly criticized by the BBC and other mainstream media here in the US for having come up with a very strong scientific theory that counters the man-made global warming theory. But she's absolutely right. If you look at cycle 25, 26, and 27, we believe they will be on the same scale as the Dalton minimum. Dr. Zarkova's research echoes that. Dr. Abdusamatov, the leading Russian theorist for this next cold epoch, says something similar. So the prediction for sunspots, to be specific in answering your question, are that the next two cycles, 25 and 26, will see no more than a 50 sunspot average at peak for both of those cycles. That will put us in the category of a Dalton minimum, which is the same level of decline in solar activity that I've been saying for the last 10 years. Dr. Abdusamatov, on the other hand, and some of his Russian colleagues believe that we'll be seeing not 50, but close to 0 sunspots, even at the peak of the 11-year solar cycles for 25 and 26, and definitely by 27. If you follow the Russian interpretation of the solar dynamic models that exist, they're saying we will be in a little ice age by solar cycle late 26 and early 27. Hopefully we aren't. I believe we'll be coming out and starting a warm-up in cycle 27. I haven't given a specific estimate at this point for the number of sunspots, but hopefully it will be back up in the 60, 70, 80 range at peak and be moderately warm, but no way will it be warm like we're going through in the last few years.
Okay, and we follow a lot of work coming over from Russia, and we do agree with what the Russians are saying.
A lot of people do, yeah.
Yes, exactly. And that is the model that we're looking at. And that, with the increase of galactic cosmic rays that are coming in, I think our TSI is going to drop even greater than that, than the Dalton.
Here's my only concern with the Russian forecast. The Russian forecast is based on a Maunder minimum. So it's important to understand the Maunder minimum the Maunder minimum was at the very bottom of the Little Ice Age. The Little Ice Age started in 1350, and the Earth progressively got colder and colder and colder until the 1600s and 1700s, the very bottom of the Maunder minimum. And then it started to warm up again, and then it got up in the 1700s, in the late 1700s, it started to cool again and went into the Dalton minimum. but then it's been climbing for 200 years. So the Earth has been absorbing lots of radiant energy and other forms of energy from the sun for 200 years. That's one of the reasons I think we're not going to be as cold as the Maunder minimum. We've been through 200 years of heating, and it's going to take some time for that to dissipate. It's one of the reasons why I think everyone has been confused over why there's been effectively no growth, but no major change either one way or the other for almost 20 years now in global temperature. Even though we've seen instances of global cooling, and more so in the last 12 months. The fact is the Earth has been heating up for 200 years. It's going to take a lot of decline on the part of the sun to cool off this very hot blue marble revolving around the sun.
Indeed, indeed.
But you may be right. I mean, I will tell you this, by the third or fourth year of the start of solar cycle 25, and I'm talking specifically in years, we're looking at 2023 to 2026. In that period of time, we will know for sure whether we're going into the very difficult Dalton minimum or the far worse case, a little ice age. We will know fairly soon how cold it's going to be. Actually, that question he gave in my answer is a very nice summary and a good endpoint for this discussion, because it says, okay, here's what we think is going to happen for the next 20 or 30 years. And it's important to understand that we will know, let's see, we're looking at the bottom of this next cycle at 2019 or 2020. We'll need 3 to 5 years, so 2023, 2025, we will know for sure how cold it will be.
Yeah, and you guys were talking about galactic cosmic rays and the cloud formation, and I can tell you it's very real. I can see it right now, and we live in the Buffalo, New York area, and we can feel it in the air. We can feel how these particles interact and almost form like a natural air conditioning in our atmosphere. But you could feel it. There's days up here in Buffalo where the temperature says 75 degrees, but the wind's blowing and your skin is cold to the touch. It's 75, 80 degrees outside.
When the sun is back on its energy output, there are real effects to that. Plant and animal life are the very first to recognize that that's changing. I have had numerous people in the agriculture industry tell me that crops are simply not growing like they used to, maturing as quickly, yielding as much as they used to.
Yeah. So, John, I have another question. I know we're getting ready to wrap it up. On the next 3 solar cycles, you're thinking they're going to be 14-year cycles based on the history versus 11-year cycle, or even something shorter than that. What are your thoughts?
I understand. We should see them longer than 11 for sure. But I'm not as much concerned with the duration as I am the depth of the drop in TSI and the increase in cold weather effects. If we use the 11-year cycle, you're looking at 30 years. If you use the 13 or 14-year extension from the smaller cycles, which we often see, then you're still looking at 26 to 34 years. Still a long period of time to be cold, long period of time to have devastating earthquakes and volcanic eruptions. It's going to be a very challenging period for mankind.
Indeed, it will be, John.
I really appreciate all the work you're doing in keeping the story of the Great Warming alive. The Eddy minimum is going to really be a turning point for the civilization of the human species. The more we can get people like you to talk about it, the better prepared we will be.
That's it.
And I don't want people to go into this difficult era of catastrophic earthquakes, volcanic eruptions, and deep cold periods with food shortages on a totally negative basis. I want people not only to be prepared, I want them to thrive. I want them to do well. If you look at every single period in human history, there's been a group of people who did well because they adjusted, they adapted, and they got ready and prepared for what was coming.
That's
Well,
exactly
and
why we're here.
we have a guest next week. We've already had him on once, and the hope is that we get to talk to you again in the future. But this gentleman that we're having on again, his name is Ice Age Farmer, and he is growing himself right now. But he's doing things like the growth of moringa. I know you've probably heard David from Adapt 2030 talk about it. But this guy
Yes.
shares all kinds of useful information: aquaponics, growing. So that's we want to get as many people involved with this conversation. We want experts in sunspots like yourself in volcano and earthquake prediction. And then we got guys like Ice Age Farmer who really know what they're doing when it comes to growing. So that's the goal here at the Grand Solar Minimum channel. And with that, John, thank you very much for joining us
again,
tonight.
John.
I can't express enough how greatly we appreciate your work and value this time that we had with you tonight. That's going to do it for us tonight, folks.
Thanks, guys.
Thanks for joining us as well. We'll talk soon.